Hey everyone, welcome. Today we're going to dive into one of the most fundamental, most important forces in the entire universe, electromagnetism. I mean, think about it. It powers literally everything from the phone in your hand to the stars in the sky. But how does it actually work? Well, it turns out the answer is less about complicated physics and more like a beautifully choreographed dance on a massive cosmic scale. Hi, you're on a rock, floating in space, surrounded by a bunch of nothing. Here at Quantum Quanta, we are here to find out what the heck is going on. Remember to subscribe, like, and share this video. Thanks. So, let's meet the dancers, shall we? Now, what if I told you the best way to wrap your head around this super complex force is to start with something we all get, gravity. I know this quote seems a little out there, right? But it's actually the perfect key to unlock this whole thing. It shows us how these two massive forces are in a way deeply connected and at the same time profoundly different. So think about it like this. We know gravity is the force of attraction between two things that have mass. You know, the more mass, the stronger the pull. Simple enough. Well, electromagnetism is kind of its twin. It's a force that acts between things that have an electric charge. But this twin, well, it plays by a whole different, more dramatic set of rules. And here's the real kicker. Gravity only ever pulls. That's it. It's a one-way street of pure attraction. Electromagnetism, though, it can pull things together and it can push them apart. This whole push and pull dynamic, this ability to both attract and repel, that's what makes our entire electric world possible. So who are the players in this game of push and pull? It all boils down to the two main characters in our story, positive charges and negative charges. Their entire relationship, everything they do is governed by one simple, super powerful rule about attraction. And well, it's a rule of opposites. Okay, so the main rule here is actually super simple and kind of funny. Charges that are the same. So two positives or two negatives, they basically find each other disgusting and they actively push each other away. But opposite charges, a positive and a negative, oh, they want to cuddle. They pull toward each other with this incredible, undeniable force. That's it. Simple, right? This one basic interaction is the foundation for absolutely everything else. So you've got all this constant pushing and pulling. You'd think it would be total chaos, right? But the movement of these charges is anything but random. It's a dance. A really elegant waltz with very specific steps and rules that control how, when, and where all these charges move. So, the first rule of this dance is voltage. The easiest way to think about it is as electrical pressure. Just like the pressure in a water pipe that's ready to burst, voltage is the potential for those charges to get moving. It's the tension on the dance floor right before the music starts, that pent-up energy just waiting to be released. And when that pressure is finally released and they start moving, bam, that's the current. This is the actual flow, the number of dancers moving across the floor. So if voltage is the water pressure, current is the amount of water actually flowing through the pipe. It's electricity in motion. But of course, no dance floor is perfectly smooth, right? The final piece of the puzzle is resistance. This is basically anything that gets in the way and slows that flow down. Think of it like a narrow part of a pipe that restricts. The water or just plain old friction on the floor that makes it harder for the charges to dance. And by the way, that friction, that's what generates heat. So okay, we've got our dancers, the charges, and we've got the basic steps. The pressure to move, the flow itself, and the friction that slows them down. But what's the music they're dancing to? What are the big overarching rules that tie electricity and magnetism together into this single, beautiful, unified force? And that's where this guy, James Clerk Maxwell, comes into the picture. He was a brilliant physicist who took all these separate ideas and observations about electricity and magnetism, and he wound them all together into one single, breathtakingly elegant theory. He basically composed the grand symphony that governs this entire force. And his symphony has just 4 parts. The first to kind of set the stage. Electric charges create electric fields around them, and magnetic poles always come in pairs. Can't have a north without a south. But the last 2, oh man, this is where the magic really happens. A changing magnetic field creates an electric field. And a moving electric charge or a changing electric field creates a magnetic field. Do you see it? They create each other in this self-perpetuating dance that can travel through totally empty space. This beautiful interplay that is light. It's radio waves. It's the prediction of a universe just filled with electromagnetic waves all zipping along at the speed of light. I mean, just stop and think about that for a second. For simple rules, that's it. This elegant dance between electricity and magnetism isn't just some abstract theory. It's the fundamental blueprint for nearly everything in our modern world, from the simplest light bulb to the most complex computer. So, let's bring all this theory back down to earth. Because this isn't just some dusty old physics concept. This is the force behind the screen you were looking at right now. The principles we just walked through are happening all around you every single second of every day. That's right. The light coming from your screen? That's an electromagnetic wave. The electricity powering it is a flow of charge, a current. The motors spinning in a fan, the Wi-Fi data flying through the air to your device, the simple act of charging your phone, it is all a performance of this magnetic waltz of attraction and resistance. It's all directed by Maxwell's 4 amazing rules. It's just incredible to think that so much complexity, our entire civilization really, can come from such elegant simplicity. And it leaves you with this one final thought. If these 4 little rules can describe a fundamental force that powers our whole world, what other beautifully simple rules are just out there waiting for us to discover them and unlock whatever comes next? Thanks for watching, and remember, if you enjoyed this video, subscribe, like, and share.